Welcome back to the shop. Today's project is a drawbar. My buddy James had a drawbar that stripped the threads on his Makini 1610L, so he sent me a print. So as you can see, it's a 7/8 inch diameter stock. I don't have any. I've got some 1-inch stock, so I'll be using that. And it calls for 4130 or 4140. I don't have any of that, so I'm using 1215, which has a comparable yield strength of about 60,000 psi, but the wear properties aren't quite as good. But you know, this should get him through a tough spot until he can get a better one made or whatever. So this is the print basically. It's just got this. This will eventually be a hex. You have 6 flats on there for a wrench. James wanted to do that himself, so I'll leave that up to him. He didn't have a lathe, so that's why I'm doing the lathe work. And then a little turn down area here, and then 4375 for most of it, and then the end gets threaded 7/16 20, so 20 threads per inch, 7/16 diameter, and 1 1/8 length. So I'm gonna, there's several ways of doing this. Maybe the most interesting part of this video for someone just want to learn about machining is how do you approach a job like this? And one way to do it would be to face off the end, countersink it, and then use a live center, and then pull it all the way out to the full length, turn the diameters, and thread just the very end, all on one setup. So that advantage is you only have one setup. If you're doing 20 or 100 parts, you'd probably do it that way. If I had the CNC, I'd probably, and I was making a bunch, I'd do it that way. But I think instead I'm just going to turn down the threads with about 2 inches of stick out without using a live center. I'll go ahead and drill it for a live center after facing it. So I'll face it, drill it for a countersink, or counter drill it for a center drill it for a live center. But then I'll just go ahead and turn this without using the live center to avoid, you know, the potential of crashing. You're doing threading and stuff. Sometimes it's nice to have a whole lot of space out here to move in there and test the threads and all that. So for me, I think I'm just, since I'll be doing all this as I go. If it's a CNC setup where you had all the known parameters, it would probably be better to do it in one single setup. But with this, I'll do the threading first. That way if I screw up the threading, I can just chop this off and go back a little and keep working my way through the stock. So that's kind of a safety insurance thing. So that's one advantage of doing this two setup job. The other is by turning threads here and not having the live center, there's less chances of crashing. It's easier to get in here and measure it and all that. So I'll do the threading part first, and then I'll loosen the chuck, move the part out, turn it on live center, and then turn down the diameters I need for in here and out here and all that. So we'll go ahead and do the facing off. I'm taking about a 10/1000th cut using carbide insert tooling. Big fan of that. And I'm doing this dry, no coolant, no oil for this part. And there goes the nib. Kind of hard working on the lathe with the tripod for the camera right in the way, but we'll muddle through. And because I am on YouTube, I don't want to do anything too awful stupid, so I'll turn the lathe off while I'm switching out to get the live center out of there. And then I'll put in a keyless chuck with the Morse taper on there for my tailstock. Put that in there, and then a big old center drill. All right. Degree of difficulty there for having the camera in the way. I'll kind of peck drill this. Probably should use a little oil on that too, but and a little more. That should be good enough for the center drill. Now I'll come in here and touch off and get a 0, and I'll just turn the diameters a bit. Alright, right there we're starting to cut. That looks like a 30. So I'll back it back off to 0, come out, and then set it for 50. So that's a 20 thousandths radius, so it's 40 thousandths off per pass. Now here's a little trick. I'm going to be threading this. I'm going to be threading this at 20 threads per inch. It's right there. So the C gearbox setting is 3, and then the rotary knob is in the A, not the B or C setting, but in the A setting. So that'll give us 20 threads per inch if the slide gear is in. If the slide gear is out, an A3 would get us 160 threads per inch. So I'm actually going to use the 160 thread per inch setting to turn down all of the radius that I need. So to turn those spindles down, I'm going to be turning those at a feed rate that would produce 160 threads per inch, a very fine thread. And then I'll go back, and all I got to do is move the slide gear from out to in. So after I get the diameter I want, I'll put the slide gear in, and then I'll be able to thread without having to do too many setups, because the setups on this thing are, it's like an old manual transmission. You got to jostle it to get them in there and all. So I'm already got A3 set on the gearbox over here. So the A is a rotary knob setting, and the 3 is, 1 to 9 setting in a funky looking transmission. I can show you a picture of that, I guess. So there's the A on the rotary knob, and then there's 3 on this weird looking transmission. It's like the kind of stuff they had on sewing machines or something a long time ago. So that's how you set the threading on here. And then there's this other setting up here to advance. That's what turns the thread, and that pulls the carriage. So that's how all that works. Now that you know how that works, here it is actually cutting. So that's 160 threads per inch, 40 thousandths depth, or 20 thousandths depth of cut, which is really 40 thousandths removal of OD, which is a medium cut on the 1 inch diameter. As the diameter gets smaller, it'll be less of a cut. It's making kind of a crumbly chip. Surface finish doesn't look all that great, but tolerable. The surface finish will probably improve significantly as we turn the diameter down. We'll probably get a better chip formation and a better surface finish. And then the last passes I do will be at a smaller depth of cut for a better surface finish as well. But as it is, I'm just going to knock this diameter down about 1.5 inches long. So it'll be a little long for the threaded part I want to do. Okay, that was 50, so I'm going into 70. So I'm moving it in 20, and that'll give me another 40 thousandths depth of cut. And there it goes, automatic feeding again. So we'll keep doing this until I get the diameter down close to the 0.4375 I want to thread. And I'll come back then and show the interesting part where you're sneaking up on it and how that works. So, see you soon. Okay, we're getting close. The surface finish is looking a little better as the material removal rate's decreasing. Still making a good chip though. I've been consistently going in an X feed of 20 thousandths on the cross slide, which is 40 thousandths OD per pass. See what we got going here. Remember, we're going for 0.4375. We are at 475. So we need to go from there to, whoops, there. So we've still got a little bit more to go. We'll take another couple of passes and then sneak up on it. Here's a little tip, by the way. If that's what you measure the OD to be, and you know you're going 40 thousandths a pass, there's 10, 20, 30, 40. So that's where the next one should get us, which would be 0.435, which is a little on the small side. It's a good thing we double checked that. So instead of 435, I want to go 4375, whoops, which is right in there. So what I think I'll do, instead of taking 40 thousandths per pass, I think I'll take a 30 thousandth pass. So instead of going in 20 to make 20 in the X to make the radius of 20 to make 40 in the diameter, I'll go in 15 to take off 30. And then that'll make that final pass about 7.5 thousandths, which should be a nice finish pass. So we're at 90 now. So we'll go into 5. So 90 to 0, and then to 5. That's 15. And then that should get us close. So here's a 30 thousandths pass. Noticeably nicer surface finish, just going from 40 thousandths to 30 thousandths. Of course, we've still got a feed rate that'll get us 160 threads per inch, so it's not going to be the greatest surface finish anyway. But if I want a better surface finish, I'll crank the RPMs up and make a slower feed rate. But this is okay for just removing material. And I'll measure this one, and then make the final pass, and then go to threading. And the degree of difficulty with the controls directly in front of the tripod is about a 9. So I'll disengage the auto feed there just as it touched off on that shoulder, and then just manually took the carriage back away from the chuck. So we're now at 445. We want to go in 7.5 thousandths from there. So we'll move this in about 3 thousandths. So we're at 5 now. We'll take that up to about 8. So this is a really small skim cut here. Get fairly close, power up, make what should be our last pass. It's not all that critical since we're going to be threading this anyway. The OD will ultimately be set by the threading. But it's still good practice to constantly try to be as good as you can. You know, use good methods that ensure accuracy even if you don't need it. Sometimes it's good to shoot for a lot better than you need. Develop good work habits, and when you do need it, hopefully you got it. So it's kind of a boring pass. Nice, pretty nice surface finish. The 12-15 seems to cut pretty well. It's making just a little crumbly chip off there though. And here we get close. Shut her down and come out and see what we got. Right on the money. Grew a thousandth or so when I was... Yeah, there you go. So 4.375. So now we're ready to thread that. Just as a crazy sanity check before we get too far into this. I've got an R8 collet, that's what's going to be threading onto there, something like that. So yeah, diameter seems right. Pushes right up to the threads. But of course no thread engagement because there are no threads. But yeah, the diameter seems just fine. And now the trick is, remember when I showed you the threading chart? So we're operating here at 160 threads per inch with the slide gear out. I'm going to go over here to 20 threads per inch with the slide gear in. All the other settings the same. So I'll knock the slide gear in. And I've got the carriage well out of the way there. That's because I'm going to test it where it's hopefully not going to crash anything. Sounds a little different. There. Didn't quite get the slide gear all the way in. Yeah, the Acme thread down there is turning a lot faster. So, yeah, this looks promising. Now, one thing I should point out, kind of important here. Let's see if I can get you off here. It's important that you catch the same number coming around each time. Otherwise, you'll take the thread pitch will be the same, but it'll be offset, and you'll end up wiping the threads. So I'm just going to catch it on 1 every time it comes around. I'll engage the feed at 1, and that way the threads, each successive threading operation will be radial in sync with the previous one, so that I'm not threading and then starting half a turn off or quarter of a turn off and wiping the threads I did before. So we'll get back up and okay, I'm going to switch from this carbide insert over to this one. It's a 60-degree included angle, so that's a threading insert. And then I'll come back over here and back it off, zero it out till it just touches, feed it until I can feel it just touch. That's at 10. Back that off to 0, and then we'll take that into 15. Actually, it was more like 15. I'll take it into 20. That first pass, the first pass is the lightest, and then as it goes deeper, that V cut. So I'll go ahead and make this one at 20, and then I'll do 25 and 30, and then I'll check, make sure once the threads start forming, I'll make sure that it's the way I want it to be. I'll double check it with the R8 collet to make sure it fits. Now we're waiting for 1 to come around on the thread gauge. 4, 4.5, 1. Nice looking curly chip. And then notice there at the end it's just going to turn a little groove there. Not much I can do about that. CNC, that's not a problem. So I'm double checking my feed is at 20. I'm going to back that off to 0 so I don't wipe my threads out. Manually return. And then put it back to 20 and then 5 more. So I'm at 25. And now I'm waiting for 1 to come around on the thread gauge again. 4.5 and 1. So now it's in the same cut it was doing before. Back it off to 0 on the X. And we'll double check the threads here. It's probably not deep enough threads, but you definitely don't want to go too deep on that. I can feel them just sort of wanting to start to catch, but not quite. Come back in here again, fire up the lathe. Waiting for the one. And there it is. And at 20 threads per inch, forgot to set it back. Alright, there's 30. Waiting for the one. Back it out to 0 so I don't wipe out my threads. And double check the thread engagement here and see if we're getting any threading. Oh, close. Hey, cross threading's a kind of threading, isn't it? Yeah, and almost going on there. So the next pass, instead of going in 5 thousandths, which is a 10 thousandths depth of cut, I'm going to go in just a couple of thousandths. So like a 5 thousandths depth of cut. We'll get up to speed. Waiting for the one. This will probably be good enough thread engagement. Back the feed out to 0 so I don't wipe out my threads. Still not quite catching. Definitely want to sneak up on this. You don't want to go too deep. Instead of having 7/16 threads per inch, you get something nasty like 13/32 threads per inch. So that was 33. Might try 35 on the next pass. Waiting for the one. Come up on the thread gauge, so we're all threads in sync. And there we go. Auto feed engage. That's a pretty good looking chip coming out of there. That's a fair amount of material removal. So that was 35, back it off to 0. Get the carriage out of the way. Oh, so close. The last one was 35. I think we're going to try 38. Take off another 5 thou or so. Really close. So dial in 38. Wait for one to come around on the thread gauge. 3, 3.5, 4, 4.5, 1. And things happen pretty quick at 20 threads per inch at this RPM, so not a good time to take a telephone call. Got to be ready to disengage the automatic feed. Yeah, definitely a fairly heavy cut. Okay, that was 38. Back that off to 0. Get clear. And see what's going on here now. Yep, real tight. think I'm going to try another pass, just a skim cut. I'm going to run it up to 38 again, maybe 39, and just take a real light skim cut this time. Yeah, looks like 38 and a half or so. Pretty heavy cut for just surprised to see that much metal coming off of there. But I bet that's pretty much got it. Nice and tight. Oh, I think I will take one more cut, maybe with a little bit of oil. I'm going to run that up to 40. Get oil on there to help it cut better. I'm using mobile thread cutting oil. Okay, waiting on the one, and there it is. Double checking, it's at 40, so it should take a light cut here. Still more metal coming off than I expected. As the thread cutting gets deeper, it definitely takes off more material, even with a slight advance in feed. You know, that's just the nature of a V cutter. The farther in you go, the wider the cut and the more material it's taken off. Yeah. Nice. Very nice. Just the way it ought to be. Oil didn't hurt too much. A little tempted to run that one more time just to clean that up. Threads look good though. I'm going to be cutting off the tip end of this threads because that's where I mean, it wouldn't probably hurt to leave the center drill hole in the tip there, but I think I'll go for the 1 1/8 inch threads here and just cut that off, and then. So I'll feed back in 40 thousandths again, so the same cut I had last time. Waiting for the one. Engage. Back off to 0. A spring cut's a good idea because any deflection in there, if you make a heavy cut, you'll get part deflection. So the threads won't be of uniform diameter if you've got thread part deflection. Little crumblies in the threads there. It was such a light pass that it made some crumbly little chips. Blowing out the R8 collet as well. Get any chips out of there so I can get a good test fit. I think we're there. Cutting threads on the lathe manual like this is always a little bit of a pain. Yeah. I think that's going to be just about right. Okay, now the deal is I'm going to use the live center to come in here and grab this. I'll loosen the chuck, move everything out so I can get about 8 inches working in here, and then I'll turn down the rest of these 2 diameters I need to turn. Actually 3 diameters I need to turn. Most of it, I think 6 1/4 inches total from here back will be the 0.4375. And then I got 0.55 diameter for I think 0.4 inches, and then a 0.875 diameter for like 0.763 inches. So I'll move this out and get 8 inches of working space there. Put it between live centers. Pretty much right on the money. Right about where I wanted to be. Good guess, huh? Calibrated eyeball. Tighten down the chuck here. Down the whoa. Very bad form to leave a key in the chuck. There we go. That's why I always do one of these before I give it a start after doing any of that kind of stuff. Okay, I got the live center in over here. That should keep it turning nicely. And then I'll switch back to this. Actually, I'll run this up and double check it on the chuck. The threading isn't quite that big of a deal, but the this one I want it to be nice and flat, even with the chuck. So I'm going to come in here and square it off with the chuck. It kind of amplifies the motion, so you can, because this whole piece is moving, you can exaggerate the motion of this and get it fairly square. Go in here and touch off. 15. I'll come back to here and call that 10, we'll go to 30. Double check everything here. Double check our print. So the overall length is a little over 7.5 inches. So I'll starting a little shy here on the threads, because I'm going to chop those threads off until they're 1 1/4 or 1 1/8 inches, which put me right about there. And then 7.5. Yeah, I actually need to come out just a little bit more. I'm going to put us a little short. All right. First cut's at 30. Double check yet again, looking for 1 1/8 the threads. 1 1/8 the threads. 7 1/2 puts me right there. That'll give me room just to part it off right in front of the chuck. A little tighter on the chuck than I'd like, but we'll live with that. So we'll engage the, running the tailstock end to tighten up the live center. Double check, make sure everything's moving okay. And now we're going for the 0.875 diameter here. So that's the first diameter we'll turn down. Of course the part's upside down in the lathe, so we're going for this diameter first all the way across, and then we'll go for this diameter all the way across, and then we'll finish up with this diameter, part it off, and we're done. I'm still at 20 threads per inch, so I'm going to pull that back gear out, get back into 160 threads per inch. That looks better. It doesn't matter where you engage this one because you're not threading. I'll go back to dry cutting, and this is going to be boring, so catch you all after I've done a whole lot of this cutting, probably 20 minutes down the road here. Okay, I've turned down this diameter to 0.875, turned down this diameter to 0.55, I've turned down this diameter to 0.4375. So now I'm going to need to switch inserts. So I've got a straight insert here. I'm going to switch back over to that 60-degree included angle insert that's used for threading. And I'm also going to use that just to put a little chamfer on the shoulder there. I don't think that's going to work. That'll cause problems. Okay, what I did was I ran it in until it just barely touched the 4375, backed it out slightly so it's not touching, and then ran it to the left until it's just starting to touch this, and then backed it off a little. Now I'll start the lathe, and then I'll just advance the Z direction to chamfer this, and then back it out. Then I'll just repeat the process up here to put a little chamfer on that edge. Doing this kind of stuff, you need to be looking every place on the chuck to make sure that you're not going to crash into something while you're paying attention to where the tool is. You need to watch where this tool is and kind of get the global view, if you will. Just breaking the edges there. All right. Two operations left to go. One is chop the threads to 1 1/8 inches of thread length, so I get rid of the part where the drill has gone in to make room for the live center, and then parting it off. So I'm not going to be able to use the live center for either of these operations. So I need to get that out of the way. So the first thing I'm going to do is back down the speed a bit. What I don't want to have happen is have all this length out there whipping around. Okay, I backed the live center out. I'll switch to my parting off tool, run it in, and I'm going to square that up with the chuck. It's important that that tool is running fairly square, because if you get into a 1-inch deep cut like this and it's not square, it'll start to bind, and that is all manner of bad. That looks pretty good. Kind of working around the tripod here. And just for sanity, that should be, that 0.875 diameter should be 0.819. These aren't super critical measurements. It looks like I want to take off. I'd previously cut that diameter so that I want to take off, leave all the part that I've turned down. So I'm going to take off the part that's not turned down. Right about there. Now it's real important to check this with the chuck, because what you don't want to have happen is that chuck to crash when you start up, because I'm working really close to the chuck here. Alright, it looks pretty good. Start up at our slower RPMs. It's good to have a little cutting oil in there when you're parting off. So I'm parting rather slowly now, just because I don't want to have anything start whipping around. I'd rather take my time on this. Don't want to part off the jaws of my chuck either. Very conservative cut. A little closer to that jaws of the chuck than I'd like to be. looking down on top now to make sure that the jaws aren't going to be hitting the parting tool. It looks okay. I like that rattly sound. This parting tool is a carbide insert parting tool, and it's really only good for parting off about 1-inch diameter, which is what this is on the OD that's in the jaws. So there's not a lot of margin for error on that. Parting tool runs better if it can stay in the cut instead of in and out, interrupted cut. And it also runs better when there's a fair amount of oil on it. Yeah, normally you can part this off rather quickly. And I'm creeping up on it. Not seeing any part deflection out at the very end where the threads are. When it gets close, it'll start to bend a little as it turns and cuts. And then I'll have a nib on the end I'll have to turn around and face off to make it pretty. Getting close. Again, if I turn the RPMs up and fed a little more, go a lot quicker. Alright, we're getting close now. Just starting to deflect on the end. And there it goes. So that's your part. We'll clean up on that and it's good to go. Take out the old stock. So there's the part, a nib on the end there I'm going to take off. And then I'll drop that down to 1 1/8 inch of threads. Alright, square up the Cut her with the chuck again. A little slower than we need to be, but won't take too long. Touch off to the face, and then just run it in to take off the nib. All right, there's that end. Okay, I've turned it around so the threads are sticking out. Go back to my parting tool here. Square that back up with the chuck. Now we got the threads just starting where the jaws end. So I'm going to run that out 1 1/8 inches. Looks like we're at 10. So we'll go back to 1, 2, 3/10, 4/10, 5/10, 6/10, 7, 8, 9. There's an inch. 1.1, 2, 5, and then the width of the parting tool. Takes us right to there. Probably should have done a sanity check with the calipers. But I got to get this thing in the post office today. Which is when you're likely to get hurt on a machine, as if you're in a hurry. Put a little slide chamfer on it with the then I'll I guess I'll go with full Monty here. There wasn't much of a nib left on there, but I'll go ahead and turn off what little nib there might have been. Again, feeding speed's way too slow on the RPMs here, but faster to go ahead and just machine it slowly than it would be to reset the VFD for a faster speed. And of course, now that I've already cut it, I'll verify it. Yay! Looks about right. Alright, James. Hope that does it for you, buddy. That was fun today. Catch you all next time with another project, I guess. But there's a drawbar. Probably ought to wire brush those threads or something, but they look all right. Final sanity check there. Very nice. Very, very nice. That's a wrap. This one's in the mail. Back to my projects already at work here. Lots of stuff going on in the shop this summer. Anyway, see you guys next time. Hope you enjoyed some of that. Maybe learned something. Maybe how to laugh at some of this. But catch you later.